intensity and area. That means electric intensity over area ds, like that. Okay, the next point, if sigma is the surface density of charge which is deposited on the sphere A, then what we can write? Sigma is equal to total charge Q divided by total area of the sphere A, 4 pi r square. Therefore, we can write total charge which is deposited on the sphere, hollow sphere A, is nothing but Q is equal to sigma into 4 pi r square. Give it equation number, what is the total charge. Now, we know that here, if we have to remove this vector sign, or if we have to write it in magnetic form, then what we can write? Here, E bar into ds bar is equal to E cos theta into ds. What is meant by theta? Theta is nothing but the angle made by the area ds with the direction of electric intensity. जब हम ये वेक्टर फॉर्म में लेते हैं, हम क्या लिखेंगे? वेक्टर ई डॉट वेक्टर ds. And when we are writing that in magnet form, that means we have to consider the angle between direction of electric intensity and area ds. Therefore, we can write this vector form in this form, that means E cos theta into ds. Theta means it is the angle made by the area ds with the direction of electric intensity. Now, for this figure, since it is uniform in shape, therefore electric area ds, it always makes, it is perpendicular to the direction of electric intensity. Here, electric intensity at every point on area ds is same. Therefore, we can say that here theta is equal to 0. That means angle made by the area ds with the direction of electric intensity, it is equal to 0, because we know that here direction of electric intensity is same for each and every point on area ds. That means theta is equal to 0. Already 180. Therefore, we know that cos 0 is equal to 1. That means we can write E bar into ds bar is equal to E into ds. Now let d phi, now listen carefully. If d phi is the small change in magnetic flux, if d phi is a small change in magnetic flux, small area ds, then we can write d phi is equal to integration of E bar into ds bar. That means d phi is equal to, if we take theta is equal to 0, then we can write integration of E into ds and total magnetic flux. Therefore, total magnetic flux is given by phi is equal to integration of d phi, that means integration of E into ds, that means phi is equal to q divided by this one, epsilon is equal to E इंटीग्रेशन ऑफ ds. अब ऐसा ds अगर हमने कलेक्ट करना शुरू किया, लाइन इंटीग्रेशन लिया आपने ds का, तो विल गेट द सर्कमफरेंस ऑफ स्फीयर B, that means surface area of the sphere B. Therefore, what we can write? E into 4 pi r square. That means here what we can write, where we should, okay, sigma into 4 pi r. Then Q divided by epsilon is equal to E into 4 pi r square. Give it equation number 2. Therefore, E is equal to 1 divided by 4 pi epsilon 0 into k r square. Yes, what we can write? Q. E is equal to Q divided by 4 pi epsilon 0 k into r square. Since epsilon is equal to epsilon 0 into k. But here charge is kept in air or vacuum. For air or vacuum, k is equal to 1. Therefore, E is equal to Q divided by 4 pi epsilon 0 into R square due to equation number 3. But we know that total charge on area on the sphere A is nothing but sigma into 4 pi R square. But as per the previous equation, we can write but Q is equal to sigma into 4 pi R square. If you put up the value of Q in this equation, therefore equation 3 becomes E is equal to sigma 4 pi R square divided by 4 pi epsilon 0 R square. 4 pi get cancelled. That means give it equation number. Okay. Therefore, we can write E is equal to sigma into R square epsilon 0 into small r square. Give it equation number 4. क्या क्या किया हमने? फर्स्ट कौन सा इक्वेशन लिया था? By the definition of electric flux and by the concept of Faraday, total tubes of induction originated from the charge Q, which normally passes through the given area, that is nothing but the electric flux in the terms of tubes of force. Therefore, we can write phi is equal to Q divided by epsilon, and by the concept of total normal electric induction, we can write the total number of tubes of induction which are originated from the charge Q that also passes normally through this given area. Therefore, in that we can also write line integral of E bar into dl bar. ये पहला इक्वेशन था हमारा. उसके बाद हमने क्या किया? By using the Gauss theorem, we are trying to determine the electric field intensity at a point outside the charged spherical shell or hollow sphere. एक hollow sphere लिया है, उस पे हम चार्ज डिपॉजिट करने वाले हैं. उस hollow sphere से सेंटर से r डिस्टेंस, स्मॉल r डिस्टेंस पे हम दूसरा पॉइंट ले रहे हैं. उस पॉइंट के ऊपर इस चार्ज स्फीयर की वजह से कितनी इलेक्ट्रिक फील्ड इंटेंसिटी है, दैट वी आर गोइंग टू डिटरमाइन. एंड फॉर दैट we are using the different concept. That means if sigma is the surface density of charge on this sphere and if Q is the total charge which is deposited on this sphere, then we can write sigma is equal to total charge divided by total area of this sphere. That means 4 pi r square. That means total charge which is deposited on this sphere A is nothing but sigma into 4 pi r square. एक इक्वेशन, सेकंड इक्वेशन लिया हमने. उसके बाद हमने क्या किया? Let us draw one imaginary concentric sphere. Concentric sphere means दोनों sphere का center same होना चाहिए. Then on this sphere here we have taken one point P which is situated at distance r. That means जो concentric sphere है उसका रेडियस कितना है? स्मॉलर है. उस डिस्टेंस के ऊपर जो पॉइंट है उस sphere पे, उस पॉइंट के ऊपर इलेक्ट्रिक फील्ड इंटेंसिटी कितनी वो डिटरमाइन करने की. उस स्फीयर को हम क्या बोल रहे हैं? गॉसियन सरफेस. दैट सिंस इट इज यूनिफॉर्म इन शेप, उसकी वजह से क्या होता है? अगर हमने उस पॉइंट के ऊपर एक स्मॉल एरिया ds लिया, दैट एरिया ds, फॉर दैट एरिया ds इलेक्ट्रिक फील्ड इंटेंसिटी at every point on this area ds is same because of the uniform shape. And that's why we can say that in the form of vector form we are writing line integral of E bar into ds, but in scalar form what we can write? E bar into ds bar is nothing but E cos theta into ds. थीटा क्या है? वो जो एरिया ds है उस एरिया ds ने इलेक्ट्रिक फील्ड इंटेंसिटी के डायरेक्शन से कितना एंगल कवर किया है. That means the angle made by the area ds with the direction of electric intensity, that is represented by letter theta. And in the form of vector we are writing this. In the form of scalar we are writing this one in this form, that means E cos theta into ds. But from the figure we can see that the angle made by the area ds with the direction of electric intensity, because both are parallel. Therefore we can say that theta is equal to 0 and cos 0 is equal to 1. If we put up that in new form, then we are writing E into ds. That means here E into ds, line integral of E into ds. अगर ये ds लाइन इंटीग्रल फॉर्म में लिया हमने तो उसका मीनिंग क्या होता है, Q डिवाइडेड बाय एप्सिलॉन E, इसका लाइन इंटीग्रल लिया तो 4 पाई r स्क्वायर. देन उसके बाद rearranging the terms, that means we are writing this epsilon in epsilon 0 form, that means E is equal to Q divided by 4 pi epsilon 0 k into r square. ये क्या है यहाँ पे, डायरेक्ट्रिक कांस्टेंट. But we know that for air or vacuum, dielectric constant K is always equal to 1, and that's why what we can write, E is equal to Q divided by 4 pi epsilon 0 r square. Then we know that from this equation, the total charge which is deposited on this sphere A in the terms of surface charge density, that is given by equation Q is equal to 6 sigma into 4 pi capital R square. If we put up the value of Q in this equation, then we are writing equation 3 in this form, and finally what we are getting, E is equal to, where we have written this, E is equal to sigma R square divided by epsilon 0 into R square. Equation number 4. Okay. Then equation 4, here we are writing E is equal to sigma R square divided by epsilon 0 R square. Equation number 4. Okay. Remove all these things. Now here case number 1. अब यहाँ पे दो केसेस हो सकते हैं. पॉसिबिलिटी क्या है, that point may be very near to the charge spherical shape or hollow sphere. इसका मीनिंग क्या होता है, small r is nearly equal to the capital R. If point P is very near to charge spherical shape, that is small r is equal to capital R. Therefore what we can write, therefore equation 4 can be written as, हम कैसे लिख सकते हैं equation 4 can be written as in new form, E is equal to sigma r square, small r is equal to capital R, that means epsilon 0 into capital R square, that means E is equal to sigma divided by epsilon 0. Equation number 5 is the first case for. Now second case में क्या होता है, case number 2. If point P is inside the charge spherical shell, spherical shell के अंदर अगर ये पॉइंट होगा, हमने कंसीडर क्या किया था, that point is situated at distance r from the point O. अब ये सब करके हमने कौन सा इक्वेशन हमें मिला, E electric field intensity at distance r due to this charge spherical shell is given by equation E is equal to sigma r square divided by epsilon 0 into small r square. सिग्मा क्या है, सरफेस चार्ज डेंसिटी. कौन से स्फीयर की है ये, स्फीयर A जिसपे हमने चार्ज डिपॉजिट किया है. कैपिटल R क्या है, रेडियस ऑफ द मेन स्फीयर ऑन विच द चार्ज इज डिपॉजिटेड, एंड स्मॉल r क्या है, रेडियस ऑफ द गॉसियन स्फीयर और गॉसियन सरफेस. नाउ फर्स्ट केस में क्या होता है, इफ दैट पॉइंट P is situated very near to this sphere, that means capital R, small r is equal to nearly equal to the capital R, then electric field intensity at point P which is very near to this charge spherical shell, then in that electric field intensity is equal to sigma divided by epsilon 0. Second case, if that point P is inside the sphere, यहाँ पे अगर होगा ये पॉइंट P यहाँ पे होगा, तो हम क्या करेंगे, गॉसियन स्फीयर ड्रॉ करेंगे. अंदर ही होगा ये, गॉसियन स्फीयर ड्रॉ किया तो उसमें क्या होगा, नो चार्ज विल बी इनक्लोज इन दैट स्फीयर. तो इसमें हम क्या लिख सकते हैं, here Gaussian surface doesn't encloses, it doesn't encloses any charge, hence what we can write, hence electric field intensity is equal to 0 inside the charged spherical shell. Is it right? That means in the second case, if point P lies inside the charged spherical shell, then that Gaussian surface or Gaussian surface that will be inside the charged spherical shell. That means that Gaussian surface or Gaussian sphere, they doesn't encloses any charge, and therefore we can say that by the concept of Gauss theorem, if closed surface doesn't encloses any charge, then the total normal electric induction over that surface is equal to total normal electric induction is equal to 0. That's why we can say that electric field intensity at a point inside the charged spherical shell or hollow sphere is equal to 0. This one is the second case. Thus we have completed first application of Gauss theorem. सबने ये ठीक से पढ़ने का, अगर कोई प्रॉब्लम आया तो we'll continue in the next periods. Okay, thank you, see you tomorrow.